Alright, on the back side, we had a couple of solves. So this one we had to solve for both x and y. Kind of our choice, whatever we want to do first. I know I've got that angle, I'm going to call that theta. So let's see, I'm probably going to use sine. I'm going to see what sine is. Sine, so that would be opposite over hypotenuse. So if I do sine of theta, opposite that is y over the hypotenuse, which is 8. But I know theta is 38 degrees, so sine of 38 is y over 8. Set it up, cross multiply. I get 8 sine 38 equals y. At that point, I can throw that into the calculator. So that's pretty good. So when I throw that into the calculator, I'm going to end up with my y value. So my y value is going to be 4.9. Just from that calculation. Now from here, I got a couple options. I could do Pythagorean theorem to get to the x, or I could use sine's friend cosine. So cosine, so that's adjacent over hypotenuse. So I'm going to say that the cosine of my 38 degrees is equal to x over 8. Now again, I want to set up my proportion, and I'm going to cross multiply. So I get 8 cosine of 38 equals x. When you do that, you put that into the calculator again, you're going to get 6.3. So we get 6.3 equals x. So if we go over to number 7, we want to solve for both b and theta. Well, I've got two sides of a right triangle. I should probably use Pythagorean theorem here. So that's a squared plus b squared equals c squared. I know my hypotenuse is always c. So that's going to be 8 squared plus b squared equals 22 squared. Alright, so at this point I got to figure this out. 8 squared is 24. So I forgot to get 22 squared down. But anyway, we get plus b squared equals 484. So what I'm going to do next is I'm going to subtract my 64 to get b squared by itself. 484 minus 64 on both sides, I get 420. I got to take the square root of both sides. So b is going to end up being about 20.5. So I can write that down here. 20.5. I'm going to fill that in up here. 20.5. Now to get theta, well, let's see. I've got the opposite and the hypotenuse. Opposite and hypotenuse. That was the sine. So I'm going to say sine of theta equals 8 over 22. To undo sine, we got to do inverse sine. Sine minus 1 of 8 over 22. And when we plug that into a calculator, we're going to get 21.3. So that's going to give us our angle on our side. If we go on to number 8, number 8's kind of a trick one. This is one of the special triangles. If you've memorized it, it's a 5, 12, 13 triangle. If not, you just have to use the Pythagorean theorem. A squared plus b squared equals c squared. 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. B squared equals 144. Square root both sides. B is equal to 12. So that was a little bit quick. This is kind of a common one that some people could memorize. It shows up a lot. But this is how we would do it. Without it, we can use the Pythagorean theorem and get through it. Over to number 9, we had to solve for x. A lot of people wrote down law of sines. We do want to use the law of sines. It's a good choice. But the problem is, to use the law of sines, we got to go angle and then side across from it. So to get x, I'd need to get this angle up here. So in order to find that out, we got to use that rule that all triangles add up to 180. So that'd be 48 plus 62 plus whatever x is. So I can add these two up. I get 180 equals 110 plus x. I can subtract 110 from both sides. I get 70 equals x. Probably should have called that something other than x, but that's that at degrees, not this x. So this x then, to do this, we'll set up the law of sines. So we'll have sine of 62 over 12 equals sine of 70 over x. We'll do some cross multiply. X sine 62 equals 12 sine 70. So if I divide both sides by sine of 62, I'll get x equals 12 sine 70 over sine of 62, at which point I'm going to go right to the calculator and I'm going to plug this into the calculator. That's going to give me x equals 12.77. So that's what I'm going to get for my value for my actual side length, x. Number 10, we also had to solve for x. It looks like we might want to use that law of sines, but if you check your triangle toolkit, you'll see that, hey, if I have two sides and an angle between them, we actually want to use the law of cosines. So we're going to use the law of cosines. That's that c squared equals a squared plus b squared minus 2ab cosine theta. So kind of our big thing is we got to figure out what c is, because c's got to be the one across from theta. Well, the angle that we care about is this one, so that's going to automatically make this c, and this is going to be little c. So this theta is c. So we can go ahead and put in c squared, which is x squared, so I may as well make that substitution also, is equal to, and a and b don't matter, you can pick them either way. It's 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine of 32 degrees. Alright, so remember here, we got to do all of this first, because this is all multiplication. Then we can add it or subtract it from whatever we have over here. The other nice thing about this is if you type it into a calculator exactly as it is, we're going to just end up at the answer. So we'll get x squared equals 91.05. If we just type this straight in, 15 squared plus 18 squared minus parentheses 2 times 15 times 18 times cosine of 32. So take the square root of both sides, we get x is equal to 9.54. So that's our value for our x right there. Now the last one on the back, this one had one special trick. Right here we had to remember that if you go along a line, you're going to have 180 degrees in total. So if I do 180 minus 56, I'm going to end at 124 degrees. So I know this is 124 degrees. Then I can use triangles add up to 180 with these two angles to get this one up here. So I can do 180 minus 124 minus 31 after that, and I can get this small angle up here. Now this small angle up here ends up being 25 degrees. So now I've got all three angles and I've got one of the sides, so I can set up law of sines. So that'll be pretty nice because I've got this one matches there, and then I've got this 25 to match with the 10, because my goal is to get this side length, which I'm going to call y. So sine of 31 over y is equal to, let's see, so that's 31, this has got to be 25. Sine of 25 over 10. We'll do some cross multiplying. 10 sine 31 equals y sine 25. And then we can solve for y, so we'll divide by the sine of 25, divide by the sine of 25. And again, we got to go back to the calculator to plug this in to see what we get. So we'll get 12.187 equals y. Alright, so at this point we know what y is. So in this triangle, since we've got this angle, we've got this angle, we've got that side, we could do some trig tricks to try and figure it out. So some trig tricks are going to be nice. So I'm going to say 56. I've got the hypotenuse. Hypotenuse is y. I want the opposite. The opposite is x. So that means I'm going to use sine. So sine of theta is so opposite over hypotenuse. So the sine of 56 is equal to x over the 12.187 from before. I can cross multiply here again, so I'll get 12.187 times sine of 56 equals x. So when I do that, I'll get 10.10 equals x.